right, so we're looking at distance and midpoint. We've been talking about midpoint already. So if we just get that out of the way, if you have two ordered pairs, x1, y1, x2, y2, if you want to find the midpoint of those 2 points, it's really just finding the average, right? Add the x's together, divide by 2, add the y's together, divide by 2. So we've been practicing that a little bit. Do you remember the distance formula? Okay, so here it is. It's really just, honestly, it's just Pythagorean theorem written for the coordinate plane, right? Because think about Pythagorean theorem, it's just a squared plus b squared equals c squared. So if I have any 2 points, right, let's just say if I had 2 random points, wherever they are, those 2. If I want to find the length of that segment, any 2 segments on the coordinate plane, you can find their length by basically turning it into a right triangle. And that length is going to be your hypotenuse, right? So it's really a squared plus b squared. It's going to get me c squared, right? So that's really all the distance formula is. It's solving for c. Okay? So the easiest way for when I'm writing it, like what I'm saying in my own head is, okay, I know I need a big old square root. I do the difference in the x's. And it doesn't even matter if you mess up and do x1 minus x2. It doesn't matter. Why? Because you're about to square that number. So whether you do 5 minus 3 or 3 minus 5, once you square it, you get the same answer anyway. So you get a little leeway if you can't quite remember, oh, was it 1s or 2s or what am I doing? It doesn't matter. So you subtract the x's, square them, and then you add to that the difference in the y's squared. Okay? So if we take a look at the example at the bottom here, you're asked to find the distance between the points and find the midpoint. Okay, so if I'm going to do the distance formula, big old square root, find the difference in the x's. So -2 minus 4, or find 4 minus -2. It doesn't matter, right? Because I'm about to close it and square it, and once I square it, it's not going to matter. Add to that the difference in the y's. So 6 minus -3 is now a plus 3. Close it, square it. Okay, remember, this is another common mistake. Sometimes kids think, okay, well look, I'm taking the square root of something that's being squared, so doesn't it just cancel itself out? It would if it was just that. Yes, the square root and the square would cancel each other out, but you have to follow order of operations. You have to do this and then add to it this number and then take the square root. So taking the square root is really your last step because you have to figure out what's in there first. So anywho, I've got -2 minus 4 is -6 squared, gets me a 36. Add to that 9 squared, 81. You can't just take the square root of each one of these and then add it together. It does not work that way. You have to add them together first. So what's 36 and 81? 117? Is that right? Double check me. It is? Okay, good. And then I just simplify that if I can, but oh no, 9 goes in, doesn't it? Nine goes in 13 times. So this is really 3 root 13. Do you have to worry about positive and negative roots? What do you think? Remember what this is, the distance formula. Distance. Do you ever refer to distance with negatives? No. Have you ever said, oh yeah, I live -2 miles from the school? No. Distance is a positive value. So we don't have to be concerned about plus minus roots because I'm solving a distance, okay? All right, so there's my distance. I was also supposed to find the midpoint here. That should be easy enough for us now. We've been practicing that. So add the x's together, divide by 2, so 1 and 3/2. You guys agree? Easy peasy? Okay. Number 2 has a little problem for us to do out. Point M, oh, okay, this is interesting. They're giving me the midpoint. And then they're giving me one of the other endpoints. So I have to, in part A, figure out where B is. Be careful, right? These are not my endpoints, so I'm not taking these and adding them together, dividing by 2. Anybody have a thought what I can do to find where B must be in order to come out with a midpoint of negative 3.9? There's a total shortcut here. I'm going to show you the algebraic way to do it, and then I'll show you the shortcut. So you have both in your arsenal, right? All right. Isn't it true that the x-coordinate of the midpoint, don't you find that by adding the 2 x-coordinates together and dividing by 2? Would you agree with that? Isn't that what I do to find that the x-coordinate of the midpoint? You can fill in all these pieces and solve for what you're missing. I just so happen to know the x-coordinate of my midpoint. It's negative 3. I know what the x-coordinate of my first point is. It's negative 12. It's the second coordinate I don't know. But now I have an equation with only one variable. I could totally solve for it, right? Multiply both sides by 2. And add that 12 over. So it looks like my x-coordinate is 6. And then you just do the same thing for the y's. So y of my midpoint is equal to the sum of the y's divided by 2. And I do the exact same thing. Y of my midpoint is 9. The first y is 2. It's the second one I don't know what that is. But now I can solve it algebraically. So that's 18 equals 2 plus y2. So 16. So that means my other endpoint, B, right, that I'm trying to find, B must be at 6, 16. Does that make sense? Do you see how I did that? There is a shortcut. 616. Here, no matter what you're doing, it's a good idea to double check yourself too, right? 616 and negative 12, 2. If I really were to add those together and divide by 2, do I really get negative 3.9? Yep, I get negative 6 divided by 2 is negative 3, and 18 divided by 2 is 9. So yes, a quick check lets me know that I have done this correctly. Here's the shortcut. The shortcut is, and I'm nervous to tell you this because some of you are going to mess up the order. You'll catch yourself if you check though, but here's what you're supposed to do. If you take the endpoint that you have to start with the endpoint. You can't start with the midpoint. Start with the endpoint that you have and figure out what did I do to get from negative 12 to negative 3. Didn't I add 6? Or 9, sorry. I added 9, right, to get from negative 12 to negative 3. Right, wouldn't you add 9 to get there? So if you just take this number and add 9 again, by golly, look, I get 6. And then it works the same way with the y's. So I was at 2, and then I went to 9, so I had to add 7. So if I add 7 again, I'll get my other endpoint. So that's your shortcut, but if you go the other way, you're going to mess it up. So no matter which way you're doing it, I don't care, but you should check your answer real quick. Just take whatever you got for A and B and make sure that really is the midpoint. All right, then in part B, they want to know how long is segment AB. Well, now that I have both points, negative 12, 2 and 6, 16, I should be able to pop that in the distance formula pretty easily. So AB is going to be the difference in my x's, so negative 12 minus 6, close it, square it. Difference in my y's, 2 minus 16, close it, square it. Now you do the math. Negative 18 squared is 324. And 14 squared is 196. 324 and 196 gets me 520. And then I would just simplify that. What goes into 520? 4 does. Anything else? What goes into 130? Any perfect squares in 130? Yeah, just the 4, I think. So I get 2 root 130. Unless I'm missing something else that goes into 130. And then, how long is segment MB? Well, you could do a whole bunch of math if you wanted to, but don't you know the answer already? Without doing a ton of math? You could do the distance formula all over again from M to B. It would actually be a really nice check. But what should I be able to do? How long should segment MB be? Exactly. Shouldn't it be half the length of AB? Since M is at the midpoint? Yeah, so if that's 2 root 30, wouldn't MB just be 1 root 30? Right? You with me? So yeah, I would recommend, if this were a quiz or a test and I had time to check it, I would check it, right? And then that would verify, yeah, okay, good, I did everything right. Okay, any questions on distance or midpoint? All right, so I gave you this other sheet. It should be relatively straightforward. You're finding some lengths and some midpoints. Let's see, I think we could maybe do one of the ones on the back. The top one asks you to tell if the triangle is a right triangle, and the bottom one tells you to determine if it's isosceles. Let's just, how would you tell if this triangle is a right triangle? You could sketch it on graph paper, but the problem is, like, it could be an actual right triangle, but it might not even look like it. You know what I mean? Like, that could be a right angle right there. It may not line up perfectly with the lines, is what I'm saying. I don't know if it does or doesn't. But I don't even need to graph it. You can. How can I tell if this thing's going to be a right triangle or not? Yes. Exactly. I would find the slopes of the 3 sides. From A to B, from B to C, and then from A to C. Don't forget about that one, right? And then just look at the slopes. If any of the pairs of slopes are opposite reciprocals of each other, that means that they form a right angle. Okay? So, we won't do this one out, but now we just told you how to do it. Find all 3 slopes. Look for a pair of opposite reciprocals. There is another way to do that problem if you wanted to do a lot more work. You could find the lengths of all 3 sides, do the distance formula on all 3 sides, and then what could you do with those lengths? Oh, come on, dig deep for that geometry knowledge. If you have 3 sides of a triangle, how do you tell if it's a right triangle or not? Yes. Exactly. You can check the sides of the Pythagorean theorem and see if a squared plus b squared really does equal c squared. And if it does, it's got to be a right triangle. But why would you do all that when finding the slopes is so much faster, right? And then the last one, let's just see if we can figure out how we would do this. How would you tell if this thing is isosceles or not? Oh, come on. Well, what's an isosceles triangle? Let's start there, right? Because if we don't know what isosceles is, then we can't do this. What's isosceles mean? How many? What'd you say? You're right, I think. Yes, 2 sides of the same length. So that's all you'd have to do here. You would have to find the lengths of the 3 sides. Okay, a little bit more annoying. Actually, I take that back. If you get lucky enough, I don't know if it is or isn't isosceles, but if you found the length of AB and then you found the length of BC and they're the same, you already know it's isosceles, so you wouldn't even have to find the length of the third one. Even if all 3 end up being the same, did you know that the definition of isosceles triangle is at least 2 sides congruent? So it could be all 3, it doesn't matter. So if you happen to pick 2 that are, you get away without having to find the third. So anyway, I would like you to finish this for homework, this sheet, okay? don't forget that we are scheduled to have our quiz on basically writing equations tomorrow. Are we okay? Yes, remember? Yeah. Oh, yeah. Okay, let me stop this here.